So this is our capstone project for senior year. It's a home radiation monitoring device where we have our central unit that interprets all of the data, and we have 3 individual sensor modules that detect seismic activity, EMF radiation from the 60 Hertz lines, as well as ionizing radiation with a Geiger counter. We'll go in depth as to how each one works in a little bit, but basically these individual modules can be plugged into the central unit, which will, like I said, interpret the readings, send it wirelessly to an online database so that users on the internet can see what the various readings are.
This is the main control unit of our device. It's kind of the brains of our entire device. It interfaces the different sensors and sends all the information wirelessly to the computer using X-speed communication. It has a little screen on here that shows you what readings you're picking up, as well as gives the user some prompts and tells them what buttons to do, push, and how to take the different readings. It's a battery operated device. It uses an X-speed, which is this wireless device here to transmit the data, as well as an Arduino Atmega as the brains.
So this is the ionizing radiation detector. We built a Geiger counter with a boost supply circuit to power the Geiger tube to count our radiation clicks. Basically, this is the operating mode. The blue LED means that 400 volts is being regulated on the power supply. It's kind of hard to see in the box, but we use, like I said, a boost supply that has just a voltage divider to a comparator so that we can regulate it at exactly 400 volts, plus or minus a few volts. And the tube requires a high voltage, which then allows ionization inside the tube when beta and gamma particles enter the screen. We couldn't get a tube that detects alpha particles, but that could be easily added to it by just replacing this tube. When the particles enter the tube, like I said, they create a quick blip of current. That blip of current is sent to our charge detector circuit, which is just a capacitor that waits for the line to dip low. And then we send that pulse through an op amp and a comparator so that we can get a pulse out every time that we have a little click inside. Pulse is then sent to the original, or the main CPU unit and interpreted as counts per minute.
Alright, we're detecting the reading from the Geiger counter now. The CPU will take the reading over 20 seconds and average it out over to a minute and display the number of counts it detects per minute.
$72.
Alright, this is an electromagnetic field radiation detector. It picks up waves that resonate at 60 Hertz. Here's the circuit for said detector. Well, it's going to be kind of hard to get out, but it has a tank circuit that resonates at 60 Hertz, which gets sent to an op amp that is a low-pass filter that sends signals below about 70 Hertz. That gets sent to another op amp, which is the actual amplifier, which amplifies a signal so it can then be sent to this. But before it gets sent, it goes through a peak detector circuit that detects the magnitude of the sine wave, the 60 Hertz sine wave, from the power line or surge protector that you're measuring. And then the Arduino picks that signal up from an analog to digital converter and displays it on the screen here. Right now we're going to demonstrate the electromagnetic field radiation detector. I'm going to turn this on here and I will take the reading. And as you move closer to the surge protector, you can see the value of the reading is increasing, and as you pull it away, it will be decreasing.
This here is our seismic sensor. It uses a accelerometer to detect changes in milli-Gs movement it works by sending the data to our Arduino, which interprets it. You can set it down on any surface, and then depending on what the surface is, you'll be able to calibrate it. Once it's calibrated, you'll be able to have it take a reading. And it's saying now no earthquake detected, but if you get to beat on the table, well, it'll say a small tremor is detected. And if you drop a really heavy book, which I don't have around me, if you shake it, it detects an earthquake, and hopefully you're not around for that.
This is our base XP module. It hooks into our base computer, which all the data gets sent to. I did some Windows 32 programming, and all the data that is getting detected by this XP gets written into a text file, which is then uploaded to our home radiation monitoring device website. As previously seen, we detected the earthquake, and it is uploaded to the website. Along with the uploaded earthquake detection in our CPU module, we have a GPS hidden away right there. Gives us a latitude, a longitude, timestamp for when GPS occurs, and it also gives that stamp for the Geiger counter.
Very nice. Very
You
nice.
plug it in. It's the wrong hole.